The famine caused by drought is the worst in living memory, and now the rains have failed again for the third year in succession. The relief organisations are doing all they can, but there just isn't enough food to go around.
Food. It feeds and gives life to us. It gives jobs to thousands of people. It is an unlimited natural resource. But that doesn't mean there's enough of it. Perhaps we don't see it, crowded and stuffed in the aisles of our supermarkets, but food depletes. It makes panic. It starts wars. And it gives famine. That's why we have scientists working every day to solve this. By means of technology, we can somewhat raise food production. A projected linear increase that is, at best, crawling along. On the other hand, human population doesn't stop for anybody. Not by doubling, tripling, or even quadrupling, but by growing exponentially. Worst of all, there isn't an off switch. When Thomas Malthus, a highly influential population expert, said that the power of population is indefinitely greater than the power of Earth to produce, he meant that there was always an indefinite imbalance between all the mouths to feed and all the food in the world. And when that precarious scale finally does tip, nations plunge into the depths of hunger and chaos, and society falls apart. That was why a change was in order. A change led by Dr. Norman Borlaug that made new varieties feeding more for less. The creation of these high-yielding varieties came to be a turning point called the Green Revolution, feeding millions from potential starvation and advancing agronomy over the world. In 1941, signs became prominent in Mexico that agrarian reform was needed. Mexico's per capita food production was decreased, and stem rust outbreaks made farmers wary of agriculture sciences. In response, American agronomists evaluated the potential food crisis, deeming it necessary to bring in a team of experts to help. Taking leadership was Norman Borlaug. In a nutshell, their task was to create high-yielding, disease-resistant wheat to rev up Mexico's food production. The months that ensued, though, were not as easy as that. The method at the time to breed new varieties was simply that, to sow and harvest. Selected wheat had to pollinate with only selected wheat, a great struggle to do for hundreds of specimens, and the results, if any, only showed every harvest. Luckily, Borlaug crossed the line. They decided to use two completely different sites. By using two different fields at two different locations, both with separate cropping seasons, they could consecutively breed wheat from one to another, effectively halving the amount of time to find the right wheat variety. Their two sites, Toluca and Ciudad Obregón, aside from having separate cropping seasons, also had different climates and altitudes, exposing the plants to different environments. This resulted in hardy, adaptable wheat that could withstand many of the environments around the world. By 1952, with the hardy plants and successive planting, Norman Borlaug was able to breed a wheat variety that had an incredible yield. But yet again, the wheat came with a setback. The wheat varieties were actually so tall that the normal stem couldn't hold it and consequently lodged or fell over, which made it harder to collect. The team looked for short-stemmed wheat so that the stems did not bend over in weight. Along with more years of breeding, by 1962, Borlaug designed a stem rust-resistant, high-yielding, and adaptive wheat variety, better than what Mexico and basically the whole world ever had before. The seed brought immediate effects. Mexico saw a production of 250,000 metric tons in 1945 that rose to 5 million metric tons in 1988 per year, a national average of 4.5 metric tons per hectare. This was a stunning increase that was thought of as impossible until then. Other countries saw these rises and went in for the benefits as well. India, needing to import 6.6 million metric tons of wheat to alleviate domestic supply, saw forecasts of a dry monsoon season in 1966. In response, they shipped in 18,000 metric tons, a record amount at that time, of the new wheat seed. The result, the wheat harvest brought in 16.5 million tons, a 46% boost in production 2 weeks. As well as that, the Pakistani government was also hurried to stop hunger in their country. The introduction of the new wheat varieties nearly doubled the production, from 3.9 million tons to 7.3 million tons of wheat. By 1980, as more farmers used the cultivar, production rose to 10.8 million tons, a stunning growth from before. As a result from the seed, world food production grew by 250% from the 1950s to the 1980s. It was a miracle seed. But the world saw other changes in agriculture from this. With the visible increased role of agronomy in agriculture, new programs started up that furthered the cause. Those include CIMMYT, the CGIAR, the ISAAA, and plenty more. Spanning areas across the world, these groups live on today to further advance agronomy. As well as that, the original wheat variety Porla helped create has helped spark new variations in other varieties, including rice and maize. All of the most widespread staples have evolved, and so with them a key trait. To have a high yield, the crop needed to have both adequate fertilizer and irrigation.
If a plant has inadequate amounts of fertilizer, it generally shows symptoms of deficiency and does not grow very well.
And that's just the problem. If you couldn't grow the plants, you couldn't reap the benefits. Developing countries like India needed an adequate amount of fertilizer, even needing to make more synthetically to keep up with demand. And of course, the use of a single more dominant crop, the high-yielding variety, sometimes had pesticide and herbicide use to keep clear of any crop-threatening diseases.
For insect control, 1 or 2 insects amongst a million may be a little more tolerant because their metabolism is slightly different, so they can break down the pesticide. But this has been a constant problem for the last 100 years.
This ever-fragile balance could any time be overthrown, and with them, hundreds of thousands of acres of wheat. And overuse of any of these technologies could lead to soil runoff, water table depletion, soil nutrient stripping, and harmful spreading of pesticides.
These should not be called high-yielding.
Numerous activists have stepped up in protest for this, but in any case, food security is stable in most parts of the world. International food prices have been kept stable. And 4 billion people since the birth of the high-yielding varieties. Supermarkets still hold bread.